G'day guys, to make an antique motorbike engine replica I'm going to need some pistons, and unfortunately 3D printed ones aren't going to work, so I've tried casting some, but so far I've just made rejects. The good thing is these rejects are close enough that I can use them to develop my tooling paths to machine them. So let's do that today. You know, I figured I'd better start machining some of these scrap pistons just to get a feel for any other casting issues I may have. Now, to machine the pistons, I need some sort of a reference so that they all come out the same. Because that pin bore is defined by the sand core, it means that the machining really has to start on the inside. This rib here is specifically added to give me a reference to work off. So I'm going to need to bring this surface here down to a defined diameter and machine a shoulder onto that boss there to give me a defined axial position. Because once I know that machined boss position, I then have a defined distance up to the center of my pin bore. So ideally, you should be able to do all of this in just 2 setups, but I don't see it working that way. And the issue is mainly driven by placing this sand core into the mold is never going to be a super precise thing. It's got a shoulder which it sits up against, but if I press it down just a little bit too hard, it's probably going to go half a millimeter in too deep. If I by mistake knock it slightly off axis, all of these features become misaligned to the outside of the piston. So the first thing I'm going to need to do is grip it from the inside, put some sort of a centering on here, and then turn this portion so that I can flip it, grip it, and clean up this part. And while I'm doing that, I should probably also bring this surface down to a defined dimension. Once I've got a countersink in this end, which is concentric with that boss, I can then grip it like that, do the outer, most of the front, the ring grooves, and then I've also got a setup I could transfer to the mill to do the pin bore, and then you'd think it's finished. But the problem is pistons aren't round. So if we look at this one here, I mean obviously not a super accurate measurement, but perpendicular to the pin bore is bigger than close to that axis. So once I'm finished making a nice round piston, I then have to go in and squeeze these sides outwards, bringing this dimension in under tension, once again turn it, and then release that pressure on it to make it an oblong, kind of an oval shape. So based on all that, I'm probably going to need more like 4 or 5 setups. Let's go to the lathe and get started. Now, one thing I've noticed is that some of my cores don't seem very well centered. Like you can see there's a bit of a sort of an angle through here. If I mount this, there really is quite a lot of wobble. Right, I'll just give it a light facing cut. Now I can center drill it. Oh yeah, that void's terrible. That's just roughed it down to a 55mm diameter. The final pistons are supposed to be 2 inches, so I've still got 4 millimeters to go. I might as well take another couple of millimeters off it and get closer. Oh, it started exposing the pin bore as well. It is good to see that the core can be quite misaligned and yet still clean up though. Oh, well, that was kind of preliminary work just to get an external feature referenced off the core. So now I can flip it and clean up this surface here. Okay, I think that worked reasonably well to bring this surface into concentricity with the outside. Okay, that's all that needs. Right, so that's the end of the preparation work I need to do. Mail time. This is from Julian. He's one of my very generous Patreons. And like all good Patreons, he knows that diamonds are a YouTuber's best friends. So this is a little monocrystalline diamond. These are the ones that I think even look like diamonds. It's been used before, but this is the sort of thing that's going to be used to give a really nice surface finish on the aluminium parts like these pistons. And along with that are a couple of polycrystalline diamonds. These are the black ones that don't make quite such pretty jewelry for a YouTuber. Not exactly sure when to use which one, but I'll ask Julian. But hey, that's awesome. And this is some sort of end mill, I guess. Looks like it's also this polycrystalline diamond. Nice. So thanks very much, Julian. I'll be setting up this one to do the final finishing passes on my pistons. Right, and here I ordered from this shop a can of boron nitride spray. When you're dipping things like a skimming spoon into molten aluminium, the aluminium will dissolve some of the steel, some of the iron, which becomes a contaminant of the aluminium. Spraying anything that you put into the molten metal with this stuff should prevent that. So 3M makes 3 different formulations of this stuff. I think one's called TG, can't remember the second, but I looked up and EP is the one you need for metal casting. And this is just some stainless steel filler wire for TIG welding. While this may look like a shoebox, I've still got plenty of life left in my basement shoes. What are these? Well, they're very, very hard sponges. This is the ceramic filter material you use in casting. The liquid metal goes in, goes through this filter. The filter catches the bifolds and contaminants and stuff that are floating around in your melt. And then from there you should have clean metal going out into your gating and into your casting. I paid for 50 pieces of the size 50 by 15. Which I think must be this size. The seller obviously threw in the big ones as well. It's very nice of them. I found these on eBay. Some guy in Germany was selling them, so perfect. Martin, the old foundryman, got back to me about this defect and said it's probably shrinkage. So if I've got these shrink defects, why? And what can I do about them? Aluminium, like most metals, shrinks as it freezes. So what you're trying to do is make sure that as your part freezes, it's got some way of getting molten liquid to backfill any shrinkage, and then you want the last bits of metal to freeze to be some features that are outside of your part. That's why we have these feeder risers on the side here, with the idea being that these stay molten last, this metal starts freezing, and metal backflows in through this web into our casting. Now if we look at this, so here's our piston wall and here's our feeder. Any T-junction is always problematic because if we look at the cross-section as a series of circles, you end up with the biggest cross-section right on that intersection. So it's going to want to stay liquid the longest. And if this freezes before that fills, then you're going to get shrink defects. And the reason is probably because these webs connecting the risers to the main casting are probably freezing too quickly and not feeding properly. Now in his 10 rules of casting on page 5051, Campbell's got this graph which basically shows you can get away with a really thick attachment where the gate will act as a feeder, or with a very thin gate where it acts as a fin. But if your gate between the feeder and the casting are sort of roughly the same wall thickness, that's when you get shrinkage defects. Designing these risers was quite difficult because in Chastain's book on pistons, there's a sort of rule of thumb of how thick this web should be. But it really doesn't take into account that this piston doesn't have a single cross section. Because you need extra meat down here for the ring grooves, you end up going from a thick section to a thin section. If you have a certain ratio of this to the thickness, at which point. And the second issue being, you also need draft to be able to draw this out of the sand. So therefore, you can see it's much thicker up here than it is down at the bottom. So here you can see the rib going from thin to thick. So at this point, I'm obviously violating that aspect of the 10 rules of casting So what can I do about it? I contacted Martin, the old foundryman, of course, and he generously came back with the following advice. Increase the diameter of those feeders and also reduce the distance to the center to shorten that web. So I've done that, printed those out, and when the weather gets warmer, I'll need to go and print them. Now, it hasn't been as cold here as it has been in the States. I was having a chat with Robert, the Infernal Craftsman, down in Texas, and I think he had 15 below freezing or something down there, which is crazy. So this week I was able to modify my match plate. Martin suggested I could simplify my runners because I'd misunderstood and had runners into feeders. But given that those are already feeders, I didn't need a second set of feeders. Of course, now that my filter's arrived, I probably need to modify this again to make a sort of core for the filter to pop into. Although I might do one casting session without filters and then modify it to add the filters to see what difference they make. And what I also got up to this week, I made some more riser extensions for my next casting session, and it was recommended that I increase the height of my pouring basin and change the shape. I've now made it to fit my slot sprue correctly. It's deeper, it's probably got a slightly smaller volume as well. Looking forward to trying those out. Yes, I've moulded enough of those for my next casting session as well. Because I'm going to have a large number of parts to machine, I put a good amount of time into handwriting the G-code. Oh, that was a bit aggressive, that cut. Given that this is not one of my better scrap pistons, I guess I have to be a little more careful about how I grip these ones. Because these parts, as cut, are going to have some variation in their length, I do have to do a bit of cutting air just to cover all of the variety in the parts. You know, this would be a perfect job to have a working tool changer. Again, here my toolpath cuts a fair bit of air just to make up for the variation of how I cut off the gates. There's a bit over 1 millimetre of finishing allowance on that. I'm going to need a mandrel to hold these parts while I mill them. To ensure that I drill the pin bore perpendicular to the boss, I'm setting up my rotary table square on the mills table, and I've also set the rotary table to 0 degrees. Then I can find center on the part itself. For a simple contour like this, I didn't bother using a CAM program. Linux CNC G-code supports the subroutines, so I just wrote a simple subroutine to loop around. Right, well that gives me a mandrel to drive between the pin bore lugs. Right, well that gives you an idea of what I'm going to use this mandrel for. Unfortunately I'm out of time for this week, so I've pretty much got most of my toolpaths set up now to be able to machine these pistons. Just need to make some decent ones. Thanks for watching.